What's up? What's up, party people? All right. What time is it? 12:49. Let's go ahead and start our timer. Hope you're having a good day. You made it. We made it to the weekend. It's Friday. Happy Friday. I only did an hour yesterday. I was gonna do another session when I got home. But I just was really tired, honestly. But I got to get out of that, right? I got to get I got to get more hours in. I've been slacking a little bit here lately, but I did have court. I had court twice this week. I got a lot of stuff going on in life. But anyway, picking up where we left off yesterday, we stopped at line 16 in things to do and 107 in save logic. So yeah, those are, I'm pretty sure I probably, yeah. Well, actually, I didn't mark it here, but I'll remember now that I read it. 106 and then 16 in things to do. And we reviewed stable save state function code. Everything looked 100% perfect. That's good. Continue working on stable save state function. Specifically added logic for ensuring data is completely transferred to stable save data table, and began adding logic for prior stable save data table. And then we stage committed our changes, blah blah blah. Okay, so now today we're gonna be we're gonna be working on stable save state function for sure. But other than that, I don't know. We'll see. We'll see what we can get to. Tomorrow's my birthday, dude. I'm turning. I don't fucking forgot. What's my age again? I think I'm turning 34. Yeah, I was born in 91. 20. Yeah, the math is correct. I think turn 34 tomorrow. So I'm getting old, dude. I'm well over the hill, and my knees can attest to that fact, dude. My knees, my back be screaming for help. All right. Let's put SQLite test on the left side. I like my shit to be organized, dude. Let's look at our extensions. We got some stuff that needs to be restarted. Boom, there we go. Make sure you do that first, because if you don't, then guess fucking what, dude? Your shit's not going to be activated, and you're going to be wondering why your autocomplete isn't there. You're going to be wondering why these little features that you usually expect to be there are not, and it's boy sound like a chipmunk. I need to use a voice changer, bro. I was thinking about it. It is what it is, though, dog. You know what I'm saying? You sound how you sound, dude. Can't help it. Oakley dokley. Usually expect to be there are not, and it's there. He is. It works. Okay. Now, peak focus, baby. Seal mix. Okay, let's see what we got here in things to do. Okay, so we added this task, create prior stable save data table. We want to create this table and associated logic for transferring data to this table and loading from this table in the case of interrupted, corrupted, stable save data table data. It's a mouthful. Save system. Add prior stable save data table, which will always be stable, is the backup table of stable save data in the case that DC or interruption occurs at time of data transfer from save data to stable save data table. So we need to create the table. So we need to create the table first of all. So let's go ahead and do that. So I would say that should happen in. So we would want this to happen in save database setup, I believe, right? We create table if not exists, stable save data. So we have three. We have save data, stable, and then we're gonna have prior stable save data, which is basically a backup of the backup. So you have more of a backup. You know what I'm saying? No, it's more of a backup, baby. I forgot to test my audio, but I heard it on when I clicked it. Okay, create table if not exists, and we're gonna call this prior stable save data. Object name, text parameter is going to be the same exact thing. It's the table used for backup in the case that stable save data table was corrupted, i.e. crash during stable save. What's it called? It's that function. Stable save state function. Function, baby. Feeling good a little bit today. I'm still tired. I'm back to work, and it's like hell week, you know. I've been out for a month, so my body's like, please no, and my mind's like, just do it. So my body's like, fuck you. I'm really tired now, and I'm running off of caffeine and lots of vitamins. So, but it's doing the trick. You know what I'm saying? It's got me ticking. That's all that matters. Okay, so create table if not exist prior stable save data. That's going to be the table name. It's going to have the same object name and value columns. The object name is going to be text primary key. Value is going to be blob. That means they got to be serialized. You know, the drill. The table used for backup in the case that stable save data was corrupted, i.e. crash during stable save state function. Yeah. Was the table used for backup loads from this upon reconnect if stable save data tables, what's the name of it? Complete, you know, dude, you know, dog. Where is it at? Here we go. Completed save data bool. Why don't you just copy it, baby? Alright, now we can control Z. Bam. In loads from this upon reconnect if stable save data tables completed save data bool is equal to false. And what else? Yeah, so this table is not recreated, is updated every time a successful completion of stable save data table is updated. This table is updated every time a successful completion of stable table is updated. Why does that sound wrong? This table is updated every time a successful completion of stable save data table. That's fine. I ain't tripping over 6th versus 8th grade grammar. You know what I mean? Fuck it. Okay. Alright, that task is complete. We have created the table. Now, next, we need to add logic for conversion of data from stable save data to prior stable save data after successful completion of data transfer to stable save data from save data. So let's go back over to save logic. We're going to go down to line 106. Boom. And here we are. Okay, so we have save system, add logic to transfer data from stable save data. Boom. So let's just go through this, what happens with this function. It takes checkpoint ID, it inserts or replaces into save data. It adds the checkpoint ID to the save data table. It serializes the completed save data bool, which at this point is going to be false. then we're going to insert into stable save data. Yeah, into stable save data, and I was just thinking about why don't we have that inserted into save data versus stable, and that's because, well, we don't need it, right? We don't need the value in save data. So yeah, we put it directly into the stable. Yep, and we pass it in as false, and that means whenever, like, let's say we get disconnected in the middle of this next section, which is going to copy all the data from save data over to stable. If it gets interrupted before it finishes and then does this line, wherein we do basically the same operation with completed save data bool, except this time it's set to true, we then insert it into stable as true. So whenever we like disconnect in the middle of this process right here, when we reconnect, we're going to first check to see what the value of the serialized completed save data bool is in the stable save data database. If it is false, well, that means like 99.9%. I mean, technically it could have crashed after it finished this, but before it finishes that. But like, you know, we're talking like microseconds here, and I would just say, you know, in that case, just go back to the previous location just in case. It's really just a safety net, and this just ensures that we're not going to be applying corrupted data. So as long as we run this line here, these two rather, which serialize a true Boolean value and then pass that into the stable save data table as true, it will load from the stable save data upon a reconnect. But in the case that, well, we create a backup of the stable just to make sure that whenever, if it does crash in the middle of that process, well, what are we going to load from then? Because the thing that we're going to load from is gone. We can't load from save data because that's always unstable. And we can't load from stable because that one's actually not stable. It's corrupted, or could be corrupted. So the last option would be to have a backup table, and that's why we created the prior. So let's go ahead and do that. We're basically going to copy, just like we did this, from save data into stable. We're going to do the same exact operation, except here this is going to copy from stable into prior stable. Does that make sense? So now, yeah, we're transferring all the data from stable save data into... Well, you know what? I just realized... Technically... Well, that one would need to... Okay, so I was realizing, like, well... Whenever we do the replace from save data to stable, we could also do the replacement of... Like, we could replace from stable to prior stable. It doesn't really matter, you know, like it's 6 one way, half a dozen the other. And like this should be an atomic operation in the sense of this Boolean starting off as false, it doing its thing, and then this Boolean being changed to true into that database. Now, I'm realizing we're gonna need to do this as well, to make sure this process doesn't get corrupted. Does that make sense? Couldn't we just wait? I think there's a better way to do this, right? Couldn't we just create a copy of the file? You know, like, wouldn't it be faster to just and easier to whenever we finished copying from save data to stable save data, couldn't we just make a backup of this file? Yeah, feel? Well, that's a table. It's not a different file. So okay, let me think about this for a second, because does that mean doesn't that imply that we could do the same thing for whenever we copy from copy from save data and then bring it over to stable table? Like, could we not just, instead of copying from one table to another, couldn't we just create a copy of the file? A backup? Like, because at this point in time, we're deeming it to be like, this is going to be what we would call a stable save state. So that means that save data would have, you know, a stable set of data that could be backed up. So we could literally just create a backup of the database file at that point in time. A backup file, like copy the entire file, and only have the one table. So instead of having save data table, save data, stable save data, and then the third backup prior stable save data, we could just have one table called save data, and whenever we ran this function, we would just basically run this first operation, which would add checkpoint ID to save data. And at that point in time, like, we wouldn't have to do any of this other stuff as far as database operations. We would just do a file operation wherein we just copied the data from the file and then made a backup of it. And whenever we load it in, like if we disconnect, we would just always load from the backup of that file. Does that make sense? So the backup would always take the place of the it would always take the place of the it would take the place of this stable save data and then having prior stable save data. I think it would, for one, it's like logically, conceptually more simple. And I think operationally, like performance-wise, it would probably be like basically the same speed, maybe even faster to do that. And also, as a security measure, it does like improve our save data integrity, security, whatever you want to call it, by having like an actual backup to a database file backup, just in case the database file got corrupted somehow. I know that's pretty rare, but like that can happen. I mean, I'm sure it can. So yeah, having a backup of the file is beneficial in and of itself. But killing two birds with one stone by using the backup of the file as the stable save state, you know, it solves two problems at once and is probably more simple, and it's maybe even faster. So let me ask Chippity Jippity the God what it thinks about this. So let's say Python SQLite 3, if I have a table, save data, and I constantly save game data to it, and I want to have a checkpoint save system wherein I periodically transfer the save data to either a backup copied database file or to a separate stable save data table in the same database file, which would be the better option concerning performance, security, cleanliness, simplicity of code. Both approaches have trade-offs, but based on your goals, performance, security, cleanliness, and simplicity, let's compare them. Copying the database file, which is a backup copy, it's very fast for large data sets. OS level file copy is optimized. Provides a full snapshot of the database, including indices, transaction history, etc. Provides a full snapshot of the database, including indices, transaction history, etc. A full snapshot of the database. Provides a full snapshot of the indices, transaction history. Simple to implement. Util. I don't know how you say that. Util. Copy file or vacuum into backup DB. If the main database gets corrupted, the backup is fully intact. Cool. And then cons, it can briefly block writes during the copy operation. Can briefly block writes to the database during the copy operation. Depends on file system and SQLite settings. More disk space usage, especially with frequent saves, and it's harder to selectively restore just one save slot. It's all or nothing. Yeah, we don't have like quote-unquote save slots. It doesn't work like that. It's not that type of game anyway. So using a stable save data table. It is more fine-grained control. You could back up specific rows, which we don't really need to do that. It doesn't require OS level file operations. It's less disk space usage compared to full backups. Easier to implement versioning. Multiple checkpoints. Yeah, we don't really need versioning per se. We don't need that. It's not like a single player game where, you know, you're gonna have like multiple save slots and like maybe you want to go back to this point, maybe you want to. It's not like that. It's online. It's persistent. It's just like one save slot, always persistent. Insert into stable save data. Select all from save data. Takes time and increases database size over time unless you delete old records, or you could just do an upsert, silly goose. Requires more SQL logic. To manage backups properly. Still needs transactions to ensure consistency. If you want quick full backup with minimal coding, use the file copy, util.copy file, or vacuum into. If you need fine-grained control and in-database versioning, use the separate table approach. For your case, frequent writes in a clean, simple system, the file copy is likely the better option. You can automate it periodically, for example, every 5 minutes or after significant progress. If you ever need more selective restores, then consider the table approach. Okay, baby, that's kind of what I was thinking. Basically, what it told me is what I expected to hear. Let's see, what's the difference between this util, which I've never actually used. I've seen it a bunch of times, and I've definitely never used, nor have I heard of, vacuum into. I guess that is a SQLite operation. Both util copy file and vacuum into can create a backup, but they have different trade-offs in terms of performance, consistency, and simplicity. So this copies the database file at the OS level. Okay. Very simple, straightforward, bam, easy. Very fast if the database file is small, which in like relative terms, I think our file is going to be very small, you know, comparatively to like millions of entries and shit. Ours only has like 50. Simple and works on all platforms, completely independent of SQLite, no SQL execution needed. But the con is if a write is in progress, the copied file might be corrupted unless you ensure no writes occur during the copy. So basically, we're not doing like multi-threading, so we're not using concurrency. This is just straight up this is like, let me think about this. Okay. Yeah, this is if we're writing to the database file, the copied that database file might be corrupted unless no writing occurs during the copy process. And since like we're not using multi-threading or multi-processing on the client side, or any sort of concurrency like that would, you know, make that happen, we're basically avoiding that issue. I don't think that would be a concern for us at all. Yeah, we don't have to worry about that at all. So that's not a concern. And then it requires external locking or pausing writes before copying. So if we were to like, there would be no point in using multi-threading anyway if we had to lock it. So you can use pragma WAL checkpoint before copying to improve consistency if using wall mode. Okay, so I do use write-ahead logging mode, but what is this pragma WAL checkpoint? Let me see. I like that, dude. Yeah. This is good. Throwing my dude a like. All right, let's go over here and pragma write-ahead logging checkpoint. Let's go ahead and see what we currently use as far as pragma. Okay, so we just set journal mode equal to write-ahead logging, and then we set synchronous to normal. That's all we do. We don't do anything else. But this is saying use pragma wall checkpoint. What does that mean? I don't know what that means, dude. But I don't know. I'll say, but we aren't using concurrency or multi-threading processing. So this wouldn't be a problem, right? So that'll be our first, and then our second question would be, you can use pragma WL checkpoint for copy use 0. Let's get him to explain this. Explain this a bit further. A bit further, baby. I need to understand. All right, let's finish. What does he say about vacuum into backup DB? Creates a clean backup of the database. Creates a clean backup of the database using SQLite. Okay. Ensures consistent backup even if writes are happening. Compacts the database, reducing file size. Works well with SQLite's write-ahead logging mode. Doesn't require external file operations. Okay. Slower than Shuto because it reconstructs the database. Requires an active database connection. So you can have concurrent writes. Slower than Shuto because it can reconstruct. It requires an active database connection. Not available in SQLite. Yeah, blah, 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 blah. Okay. If you need speed and simplicity, use utility copy file, but only when you can ensure no writes are happening. If you need data integrity and a clean backup, use vacuum, especially if writes happen frequently. Since your game does frequent writes, I strongly recommend because it guarantees a valid backup without stopping your game. Okay, 3, so vacuum allows concurrency. No concurrency is copy file save. If you're not using concurrency, no threads or process modifying the database, then should generally be safe. You're not in the middle of a transaction when the copy happens. No, we don't do that. Each commit, it auto commits for each operation. Therefore, I'm pretty sure like that is its own transaction each time we do an operation. SQLite is not writing. Since I am using auto commit, doesn't that mean I wouldn't be in the middle of a transaction? Okay, and then SQLite is not writing to the file at the exact moment of copying. Since SQLite writes are atomic, as long as you pause writes before copying, you should be fine. So if I run the copy file immediately after a cursor.execute, I should be safe. Or could the DB file be operated on from that line even after the line, the interpreter moves on to the copy file line? Okay, let's see. Since SQLite writes are atomic as long as you pause writes, what does pragma while checkpoint do before copying? If you're using write-ahead logging mode, then SQLite writes to a separate write-ahead logging file instead of modifying game data database directly. This means that if you copy game data database without the write-ahead logging file, your backup might be missing the most recent writes. Oh, see, I didn't even think about that, but I'm using write-ahead logging. I would not have thought about that. So, solution to this is to run this before copying. You run pragma while checkpoint full. Flushes recent changes into the main database file. Okay, so this forces SQLite to merge the while changes back into game data DB, ensuring that a copy file is fully up to date. Okay, for sure, for sure. I understand. Would have to be run every prior to every file copy operation, operation, baby. This for SQLite, blah blah blah. We already know. Does vacuum into allow concurrency? Yes. It does not block readers or writers. Unlike regular vacuum, which locks the database and prevents writes, vacuum into creates a copy of the database without interfering with ongoing transactions. This means your game can keep writing to game data DB while your vacuum into backup DB runs in the background. If you're using write-ahead logging mode, either use pragmal checkpoint full before you shoot till a copy file, or just use vacuum into. If you're in a rollback journal mode, it's usually fine. If you want to save backup without stopping writes, vacuum into is the best choice. Okay. Does auto commit prevent mid-transaction copy issue? Does auto commit prevent mid-transaction copy issue? Yes, auto commit mode ensures that every cursor executed is a standalone transaction. This means that as soon as insert, update, or delete statement completes, the changes are immediately written to the database. However, just because Python moves on to the next line doesn't guarantee the OS has finished writing the file. SQLite writes happen fast, but the file system buffers and disk I/O operation can introduce a slight delay before everything is truly written. Are you safe to run immediately after? In a rollback journal mode, usually safe because transactions are atomic. In write-ahead logging mode, not necessarily safe because recent changes might still be in game data database while not yet merged into game data DB. So concerning the slight delay with moving to the next line and then copying, if we are using WL mode but run while checkpoint full immediately prior, the line before the copy operation, would that be a risk of concurrent access to the database file? Okay. Does pragmal checkpoint full need to be run before every file copy? Yes. If you're using write-ahead logging mode, you should run pragmal checkpoint full before every backup operation. Before every backup operation. Why? Write-ahead logging mode writes changes to instead of game data DB. Forces SQLite to merge recent wall changes into the main database file. Without it, if you copy just game data DB, the backup might be missing some of your recent writes. How to ensure safe copy? So we do bam, 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 and then gotcha. All right, let's see. Could there be a risk of concurrent access when running while checkpoint right before? No, there's no concurrency risk in your case since you're not using multi-threading or SQLite yourself or the OS is performing a delayed file write from checkpoint full, then there's a small chance could start copying while the OS is finalizing the write. This is not concurrent access and usually rather a potential file system timing issue where the copy operation might catch an incomplete write. Why this is usually not a problem is a blocking operation. It doesn't return until the WAD is fully written into. SQLite guarantees atomicity of database writes, so once checkpoint full completes, the database file should be in a valid state. SQLite transactions are designed to be safe even if the program crashes at any moment. Potential edge case: if OS level file I/O caching is involved, e.g. delayed disk writes or SSD controller caching, the file system might still be writing when shootability starts. This is very possible in systems with aggressive disk caching. How do you want to ensure the database? To ensure it has fully written the change before copying, you can flush the file system buffers with fsync to ensure the OS has fully written the changes before copying. You can flush the file system buffers with fsync before shoot to copy file. So then we would do checkpoint full, and then with open db path rb as f, And this is the database path. Okay. So we run pragma wall checkpoint to transfer from the wall file to the actual DB file. Then we force the OS to flush any pending writes with the fsync. Okay. Ensures all data is physically written to the disk. Gotcha. And then we copy the database file. So this is the safe approach that ensures we would never encounter this like slight delay issue where we might be dealing with an incompletely written, aka corrupted file. That's not good. We don't want that to happen. So no, there's no concurrency risk because you're single threaded. In rare cases, file system buffering might delay writes, but adding fsync ensures all data is fully written before copying. If you want the safest approach, use vacuum and DB instead of everything internally. Gotcha. Well, in this case, I might just use vacuum into. Y'all feel? That makes sense to me, dude. You know? If I gotta do the fsync and the wall checkpoint full, you know? So if using wall mode and then vacuum into, it avoids these potential write delay issues altogether. Yes, vacuum into complete avoids these write delay issues in wall mode. Unlike ensures all data, including uncommitted wall writes, is correctly transferred to the backup file in a fully consistent state. It's no need to manually run. It automatically includes all WL data in the backup. There's no risk of missing recent writes. No OS level file I/O timing issues. Vacuum into reconstructs a fresh database file using SQLite's internal logic. It does not rely on the OS file system's ability to flush writes correctly before copying, and there's no locking issues. It does not block writes, and your game continue working. Cool. Okay, so I think I'll probably, in this case, go ahead and just use the vacuum into. Should you ever use, if you're in roll mode, is riskier because it requires manual pragma and possible fsync. If you're in rollback journal mode, it's fine. Okay, yeah. So we're gonna use vacuum into because we do use write ahead logging. I know this, if you're trying to track with me here, this is confusing, but yeah, I feel it's like safer, dude, and easier. So we're gonna just go with that. Let's go over here, and so where are we gonna add this? Okay. So we're redoing this. We're redoing this. This is gonna be it's gonna be completely different now. We're not gonna use the stable save data at all. We're also not gonna use the prior stable save data at all. We're only going to have the we're gonna have two files. We're gonna have the original database file, and then we're gonna have our stable save data file, which that's gonna contain our the stable save state whenever we run that vacuum into. So I am concerned though, what happens if in the middle of the vacuum into line we get interrupted? If we get interrupted, in that case, well, that means, you know, then, like, what happens? Let's ask, what happens in that case? Because we are concerned about this. What happens if vacuum into line crash in middle of operation? In the weird English, it'll understand because it's smart. If vacuum into crashes in the middle of the operation, your main database remains completely intact and unaffected, but the backup file will be incomplete or corrupted. Vacuum into creates a new file instead of modifying the existing ones, unlike regular vacuum, which rewrites the same database file. Vacuum into creates an entirely new database. Since game database is only being read and not altered, it remains safe even if the process crashes. The backup file is built atomically. SQLite writes data into backup DB in a structured manner. If a crash occurs, backup DB may be incomplete or corrupt, but game data DB remains untouched. SQLite writes data into backup DB in a structured manner. If a crash occurs, backup DB may be incomplete, but game data remains untouched. Writes to the main database can continue. Okay. How to handle a crash. If you're worried about crash, consider checking for backup completion. Check that it is valid. Try and then verify the backup is valid. SQLite database. If OS path exists, with SQLite 3, connect backup path as testcon. Testcon execute pragmatic integrity check. This ensures that the DB is not corrupted. Okay. Using a temporary backup file before overwriting. Instead of directly writing into backup, you use a temporary file and rename it only if the operation succeeds. Okay, that makes sense. Which is basically like the same thing that I was currently doing with save data, stable save data, and prior. But in this case, it's 3 different files instead of 3 different tables. We have the just like regular save data. Then we would have backup temp, and then that's the one that's gonna be well, I don't know, like, isn't that kind of silly though? Because, well, no, it's not silly. It's not silly at all, because it ensures that you always have a stable backup. You know what I mean? Yeah, you always have a stable backup. So you write from, or rather, you always write saves to save data. Whenever you go to create a stable backup state, you would vacuum to temp backup. So the very first time you ran this operation, you wouldn't technically have a backup, but every subsequent write, every time you did that operation later on, you would have the stable backup, which would be the previous stable state. Save data is going to write to backup temp, and then when it's completed, it will then transfer that data into from temp to the backup. But I'm like, I'm a little bit extra here when it comes to making sure everything is 100%. I know the importance of that based on my experience with like little rare issues causing intermittent bugs and just headaches in the future. So like I have even a better, safer idea, I think. And that would be I don't know, is it safer? I'm trying to think. Basically, we would have save data, then we would have backup temp, and then we would have backup, and then we would have like second backup. And the reason for the second backup would be, and God, it would probably almost never happen, but it could, right? So it does cause more logic, but it's safer. So we would have save data. It saves to temp. It starts that process. Whenever that finishes, for the first time this happens, it will transfer the data from temp to backup. So now you have a stable backup, and then the unstable save and a stable temp backup, but it might be corrupted in the future, right? So any subsequent save to that, you would go save data to temp. At that point, temp is at risk of not completing the operation, right? So first time around, you go temp you go from save to temp. When that completes, you duplicate temp and call the duplicate the backup. And then you create, I don't know, I think this is necessary for complete integrity. Then you create the second backup. Now, after that, whenever you do save data to temp, temp is at risk, but when it finishes, it will go transfer to backup. Now, if it were to crash in the middle of that process, what would you fall back on? Well, you would fall back on second backup, because that one would be, you know, completely up to date. Well, regarding the last time you did this operation. Now, I guess you could say that temp would at that point be the equivalent of the second backup. Does that make sense? So instead of having save, or we could call it current, temp backup, backup, and second backup, instead of having 4, we could just have 3. And we would have current, backup, or rather current, temp backup, and then backup. Whenever you ran the save operation, it would copy from current to temp. Once temp completed, it would then duplicate it to backup. Now, unless it happened on the very first time you ran that operation, you would have temp as a safe backup, and you would have backup as a safe backup. Now, in the future, if you failed, let's say you're in the middle of going from current to temp and it gets corrupted, well, you revert back to the last backup point. But in the case that it succeeded on that second time around, going from current to temp, that would mean you have temp is a valid backup, like it's a stable state, right? So then when it goes to copy temp over to backup, let's say that one gets corrupted, which causes the backup file to be corrupted. Well, in that case, when you loaded, you would load from temp because it's successfully finished. You know what I'm saying? So in that sense, you have two versions of you have two backups. So I know that's a mouthful. It's kind of a lot to parse. I want to make sure I get this right though. I don't like throw code. I just don't throw code up anymore. It's got to be like pretty much perfect before I go forward. It's just how I operate now. I've learned the benefit of doing it like that way. That's just, it's worth it, right? So, few things. I'm gonna just go over here, and we're gonna put this in things to do because there's a lot going on with that, and I want to write this down first because my time's almost up anyway. I'm gonna go to the gym, but I want to write this down, and I want to make sure like I have this. I just have it written down, you know, so I don't forget anything. So we're gonna say revised save backup system, and let's just put revise save, or we'll just call this save system. What do we call it? Save system. Yeah, save system backup schema to use files instead of multiple tables. So replace, well, we're just gonna write like how we're gonna structure this. So we're gonna have three files, three database files. We're gonna have we'll just say save data, I guess. Temp backup, and then backup. All right, does that make sense? Now we're going to say save data equals current / unstable. Temp backup equals stable unless corrupted, and then this would be checkpoint, and then we have backup, which is, it's basically the same thing. It's going to be checkpoint is stable unless corrupted. And the way that we're going to do this is we're going to, well, we already discussed it, but we already discussed it. It's disgusting. So transfer from save data to temp backup. If this fails, or if this gets interrupted, unless first time operation, load from backup. If this succeeds, but, well, yeah. Well, actually, you know what? I'll just copy this line because this is a little bit confusing. It's not really that confusing. We copy this, and then we say transfer / copy. However we're gonna like do this, we have to figure out the details of that, right? I mean, I guess it's cool that I learned. It's always good to learn. So I did learn how I could do this using multiple tables. But personally, I think the multiple file thing is just, it's better. You need a backup file anyway, blah, blah, blah. So anyway, we transfer copy from save data temp backup. If that gets interrupted, unless it's the first time operation, load from backup upon DC. And then after that's completed, we transfer copy from temp backup to backup. So that acts as our double. If that gets interrupted, unless it's first time operation, well, even if it is the first time operation, temp backup would still exist successfully because that precedes backup, right? So then we would load from temp backup. If this gets interrupted, load from temp backup upon DC. It makes sense. This allows for always having stable save version despite corruption slash interruption. Yeah. 7 more minutes. Okay, now yeah, so that means we're gonna have to so tasks, we're gonna say next tasks. However we want to figure this up as far as writing it. So the next thing would be to remove all code associated with multiple tables. Add code for multiple files. Then we're going to determine how exactly to copy transfer data from file to file, database to database. Implement this logic, or implement logic associated with copying slash transferring data from file to file, and then review all code. So that's our next task, and we're going to go ahead and put stopped here. So 4425 stopped here. Let's copy that. Okay, so this is line 26 in things to do. So right here, we'll put stopped at line number 26 in things to do dot text blah 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 1251 to 153. We continued working on stable save state function. Specifically, we decided to change save state schema to use multiple files instead of multiple tables. Consulted ChatGPT and created a first pass outline of replacement logic, etc. And then we stopped at line 26 and things to do. Okay, cool. Now we're gonna go ahead and stage and commit our changes as well, and that's gonna happen from 154 to 155. And I have to work tomorrow. Don't forget. Sometimes I forget because I didn't used to work Saturdays, so it's kind of like don't forget, dude. It's like, oh, it's Friday, we're off for the weekend. It's like, no, you're not. You gotta work Saturday. So that was 1 hour. Okay, because we actually have 3 minutes left, but I'm basically done. Yeah, so 1 hour. All right, let's go ahead and copy this. Now we're going to go over here. We'll do git branch. We'll first check to see if we're in the correct project, the correct directory, which is the root project directory. We are. That's capital C Canasta. We're going to do git branch to make sure we're on the correct feature branch, which we are. Do git add dot. To add everything, we do git commit dash m. We do double quotes. We paste in save system table save function additions, and this is actually going to be called additions / revision, whatever. And so let's add this in here. Well, I actually can't, the way that, I don't think it lets me just, yeah, it doesn't just let me click. I can just do this though. It's a little faster than copying and pasting it, I guess. We just go right back here and then / revision. There we go. Okay, and then it's got all the time stamps and all that stuff. 3 files changed, 35 insertions, 6 deletions. So we successfully committed. Now we're going to push to the upstream remote GitHub repository. There, it did its thing successfully. Beautiful. Now we can go ahead and close this out. We're going to minimize this. Holy shit. Recursion, baby. Now we're going to go open up the programming file, and we're going to, a folder rather, we're going to enter into Canasta, copy the current version. We're going to go into backup. We're going to delete the old one, and then we're going to paste in the new one. Out with the old, in with the new, and we're going to verify by looking at the devlog of the one we just pasted in and just checking that date, make sure it's up to date. It is. So now we go back to the folder for the backup and we rename it with today's date, which was the last time we created a new local backup. Alright, so we're done, and I will see you later. Maybe I've been slacking on my second session just because, oh god, I just was tired. And when you can't really code when you're tired. It's like trying to do calculus when you're like falling asleep. You know, you're either in it or you're not. It's like getting in a fist fight. Like you're either in it or you're not. You're awake or you're not. There is no in between. There is no, oh, I'm just gonna like code a little bit in the background while I'm not really paying attention or while I'm half asleep. Yeah, don't do that, because you're just gonna fuck up your project, and then it's like, don't do that. You know, if you ever worked on like a really big art project or anything, you don't want to work on it when you're like not in the right zone, because then you could just fuck it up. You know what I'm saying? Anyway, alright, so there goes the timer. Time's up. See you later. Maybe. We'll see. Either way,